For a question like this, there's a lot of blanks to fill in. And like any complex question or problem, you just have to break it up into smaller pieces and attack one piece at a time. And if you come across a part you can't do yet, try something else, try another area, and maybe by accomplishing that task, it will help you with another task. So we have Cannonball launched from a cannon that's sitting in a trench and it moves through the air following this path. And we have 4 points, A, B, C, and D, and we have some questions about each point. It tells us right away that the kinetic energy at A is 3,500 joules, and it wants to know the potential energy. And if you look, the cannonball is at ground level. There's no height. And as you know, the potential energy, gravitational potential energy, is mass times gravity times height. So if the height is 0, there is no potential energy, at least gravitational potential energy. There's no springs involved, so there's no regular potential, there's no any potential energy here, no gravitational or elastic. Now, right away, this tells us something really important, is that the total mechanical energy, which is just the sum of all the energies involved, is 3,500 plus 0. So if we can remember, keep in mind anyway, that the total mechanical energy is 3,500, that means every single pair is going to have to add up to 3,500 joules. So we finished with A. Looking at point B, I mean, we could probably figure this out because we're given the height here is 10 meters. We know the mass of the cannonball is 4.5 kilograms. And if we just use this equation here, well, that should help us figure out the potential energy. So let's do that. So in this case, at B, the mass is 4.5 kilograms. Gravity is 9.8. We'll call it newtons per kilogram. And the height is 10 meters. And so when you multiply all those together, it turns out the potential energy is 441, and kilograms cancels out. We're left with newton meters. And a newton meter is a joule. So for our potential energy here, because we had our height and our mass, we can say that the answer is 441 joules. Now, the total between the two has to add up to 3,500. So if we take that 3,500 and we subtract our 441, well, that tells us that this must be 3,059 joules. So those add up to our total. Traveling further along, we get to point C. It tells us the kinetic energy is this number right here, 2927. Right away, we can just do the subtraction again. It should be, the total is 3,500 minus 2927. And so our potential energy at this point is 573 joules, which is nice because we're trying to find our height here. We want to know how high up this is. And so once again, we go back to this equation here. And we're just going to rearrange this to solve for height. If we just take both sides and we divide mass and gravity by both sides, then what that tells us, this is point C, that the height will be the potential energy of gravity divided by mass times gravity. And we plug our numbers in. We know the potential energy is 573 joules, or we'll just put newton meters, those are joules. Divide that by the mass, which is 4.5 kilograms, and times gravity, which is 9.8 newtons per kilogram. And when we solve that, let's see, kilograms will cancel out down here, newtons will cancel out with there. And at point C, we're going to find out that this thing went, we'll just round this to 13 meters. Okay. Once again, just keeping in mind the total mechanical energy and using these equations. This equation right here, just rearrange it to solve for our variable. In our last spot right here, D, we're given some more blanks to fill in. This looks like it's right like the instant before it touches the ground. If you see something like this, just assume that's the instant before it touches the ground. So right away we know that our potential energy is going to be 0 joules, which, I mean, to add up to 3,500, that's going to have to be 3,500 so that we have our total. And then we had to find velocity. Well, velocity, we can use the equation where kinetic energy is equal to 1/2 mv squared. There's our velocity right there. I want to give velocity by itself, so I'm going to divide both sides by 1/2 m. So kinetic energy divided by 1/2 m is going to be equal to v squared. And now we don't want v squared, we want v. So we just need to take the square root of both sides. So let's write that here. Kinetic energy 1/2 m. If I take the square root of that, will be equal to velocity. And I'll just plug my numbers in. Let's do this over here so it looks okay. So kinetic energy is 3,500 joules. Instead of half, I'm going to write 0.5 just because that's how I'm going to put it in the calculator. And the mass is 4.5 kilograms. And we need to take the square root of all of that. And when we do, if we put it in our calculator correctly, we find that we get 39.4, and the units end up canceling out meters per second. So I'm going to write that in here. 39.4 meters per second. That's how you do it. Again, just you have your total mechanical energy. Once you figure that out, you just use the different equations to solve for what you need.